So we are taking up the fifth problem. So here limit x tends to 0, sine hyperbolic function we have got here, sine hx minus x is there, divided by sine x minus x cos x. Okay. So here we will name this particular answer for this limit as what? P. Any variable you can take. Now the p value, now apply the limit, what happens? Sine 0 minus 0 divided by sine 0 minus x is also 0 into cos 0, right? So what's the answer you are getting? Sine 0 is what? 0, 0 minus 0 divided by 0 minus 0. You are getting 0 by 0 form, right? So after getting 0 by 0 form, we have studied that we are going to apply the L'Hospital's rule in order to get the limit value for the following function. Now L'Hospital's rule says what? Whenever getting 0 by 0 form, we have to differentiate the numerator and denominator separately, not together. Together in the sense we cannot apply here u by v rule and come, okay? So here u by v rule cannot be applied. We have to differentiate the numerator as well as the denominator separately. There is a thing. So p value limit x tends to 0. This particular function we are going to differentiate. So sin hx differentiation is what? Cos hx minus x differentiation is 1 whole divided by sin x differentiation is what? Cos x. And here this particular thing we have to apply the product rule, u into v rule, uv rule you might have studied. So how to apply uv rule? See, remember, uv rule basically says u is the first function, v is the second function, vice versa also you can take. First function into differentiation of second minus, sorry, plus second function into differentiation of first. This is uv rule. So this particular thing we are going to apply. X will take u and this particular v, cos x will take v. Be careful, minus sign is sitting outside. So I'll just keep minus sign outside. Okay, now we'll differentiate. First function as it is into differentiation of second. Cos x differentiation is minus sin x plus second function as it is, that is cos x as it is. This differentiation of first function which is x, it is equal to 1. Now this particular thing can be rewritten as, or simplified version will be cos hx minus 1 whole divided by cos x minus you multiply it will be plus x sin x minus cos x. I hope you understood this particular thing. Now we can apply one. Now here cos x and here minus cos x will get cancelled. So the simplified version we are getting limit x tends to 0 cos hx minus 1 whole divided by x into sin x. Now here we can apply the limit. When you apply the limit, what happens? So let us see. So after applying the limit, this becomes cos 0 minus 1 divided by 0 into sin 0. Now what is cos 0 value we are getting? It is 1. 1 minus 1 divided by 0. It is 0 by 0. Again you are getting 0 by 0. So what to do again? Again we have to apply L'Hospital's rule. So which function we have to consider? Now the previous, before applying the limit where you are getting 0 by 0 form, this limit, that particular function we have to take. So this particular function we have to consider. Then differentiate again. So the differentiation will be doing cos hx. So first you write limit x tends to 0. Limit is very important. Okay. Cos hx differentiation is what? Sin hx. Then minus 1 differentiation we know it is 0. Constant value differentiation is always 0. So no need to write. Divided by. Again we have to apply what? UV rule. Right? U will take this one. V will take this one. Because both are the function of x. That's why we have to apply UV rule. Okay. So first function as it is into differentiation of second. Sin x differentiation is cos x plus. Second function as it is into differentiation of first function which is 1. X differentiation is 1. So the simplified version can be written as sin hx divided by x into cos x plus sin x. Now here we have to apply the limit. So limit, when you apply to remove the limit, so substitute the value 0 here. So sine 0 divided by 0 into cos 0 plus sine 0. So sine 0 we know 0 divided by 0 plus 0, sine 0 we know 0. So what the thing is that again you are getting the 0 by 0 form. Again you are getting 0 by 0 form. So what you have to do? Again you have to apply L'Hospital's rule. So that means the previous function where you are getting what 0 by 0 form, which function was that? This particular function. So before applying the limit, whatever function is there, that particular function we have to take and again differentiate. So sin hx differentiation is what? Cos hx. Okay, remember these two formulas, d by dx of cos hx, it is sin hx, and sin hx, it is cos hx. No minus sign and all. Okay, remember two formulas. This we are applying here. Okay, that's why I wrote. So okay, fine. Now here, what is the function we have got? This function and this function. Again, here if you observe, we have to apply UV rule. We will apply UV rule. First function as it is into differentiation of second. Cos x differentiation is minus sin x and plus cos x as it is into differentiation of x is 1 plus sin x is sitting, differentiation is nothing but cos x. Done. Now we have to apply the limit, and before that, okay, we'll directly apply the limit, no need to simplify. So we'll apply the limit. What happens? Cos 0 divided by 0 into minus sin 0 plus cos x is 2 cos x, but directly we'll apply cos 0 plus cos 0. Anyways, it's the same thing. Cos 0 value is what? 1 divided by sin 0, this thing is 0 plus cos 0 value 1, again cos 0 value 1. If you write 2 cos 0 also same thing, 2 into 1 is, we'll be getting 2 as the answer. So 1 by 2 we are getting. So now we are getting the some value other than 0 by 0, indeterminate form. Other than that, we are getting some value. So this will be the answer. So p value, the answer for this limit for the following function is given as what? 1 by 2.